Sum number 3. 3x minus y is equal to 3. 9x minus 3y is equal to 9. Let's solve it by substitution method. First, let us number the equations as equation number 1 and equation number 2. Now, consider one of the two equations. Which equation is to be considered? Either, whichever you feel is simple. If you feel first is simple, let us consider equation number 1. 3x minus y is equal to 3. Now, write it either in the form of x is equal to something or y is equal to something by shifting one of the variables to the other side. Say if you shift y to the other side, you get x is equal to 3 plus y upon 3. Is this thing very clear? Now number this equation as equation number 3. Name of the method? Substitution method. So we need to substitute something. Substitute what? Equation number 3. Where? In the equation that we did not consider. In this case it is equation number 2. So let us substitute equation number 3 in equation number 2. What do we get? 9 bracket, in the place of x you will write y plus 3 upon 3, right? Minus 3y is equal to 9. 3 3s are 9. You can cancel. Now let us open the brackets. 3 into y plus 3, you will get 3 into y plus 3 into 3, that's 9, minus 3y is equal to 9. Now something interesting. See what happens now. Plus 3y and minus 3y gets cancelled and you are left with 9 is equal to 9. Now what happened here? X got cancelled, even y got cancelled. You don't have any variable left here. You are getting something like 9 is equal to 9. Now since both the variables are getting cancelled on solving, x we eliminated by substituting and y got cancelled here. We could not find the value of y, so there is no question of you finding the value of x. Now in such type of sums, if you get something like this, the conclusion that you need to write is these equations do not have a unique solution. So what do these equations have? If they don't have unique solution, then what? You will understand this once we start with the concept of something called as consistency. So you'll have to wait till there. As of now, just understand when you get something like this, 9 is equal to 9, the variables getting cancelled, just write a conclusion. These equations do not have an unique solution. As simple as that. Okay? Chalo. Let's move on. Next sum number 5, roots. Root 2x plus root 3y is equal to 0. Root 3x minus root 8y is equal to 0. Let's solve now. Roots hai, calculations easy, but you need to take care. Let's start. The first thing that we need to do is write both the equations and number these equations as equation number 1 and equation number 2. Now consider one of the two equations. Which equation is to be considered? Whichever equation you want to, whichever equation you feel is simple. In this, if you feel equation number 1 is simple, let's consider equation number 1. Equation 1 is root 2x plus root 3y is equal to 0. Now write it in the form of either x is equal to something or y is equal to something. How do we do it? By shifting one of the variables to the other side. Let's shift, say, y to the other side. You get root 2x is equal to plus root 3y goes to the other side. You get 0 minus root 3y, that's minus root 3y, right? We want to write it in the form of x is equal to something, so that root 2 comes to the other side now. When root 2 goes to the other side, it goes in the denominator and you get x is equal to minus root 3y upon root 2. Number this equation as equation number 3. Clear? Name of the method? Substitution method. So what we need to do? Substitute. Where we need to substitute? Whichever equation was not considered, and that is equation number 2. So now let us substitute equation number 3, that is x is equal to minus root 3y upon 2 in equation number 2. So in equation number 2, in the place of x, you substitute minus root 3y upon root 2. Let's see what happens now. We get root 3 into minus root 3y upon root 2 minus root 8y is equal to 0. Clear? Now, very important bracket we need to open. Root 3 into minus root 3. Root 3 into minus root 3 is minus 3. This is clear? One mistake that you all can do here, don't multiply that root 3 with root 2 also, because root 2 is in the denominator and root 3 is in the numerator. So, numerator will only get multiplied with the numerator. So, root 3 will only get multiplied with minus root 3 and you get minus 3. Clear? Root 3 into root 3 is 3. Now, what happens to the denominator? We take the LCM. Here you have root 2 in the denominator. There you have 1 in the denominator, root 8y upon 1. Right? So, now let us multiply LCM concept, root 2 with root 8. Now, root 2 into root 8 is root of 2 into 8. That's root of 16. And what is root of 16? Root of 16 is 4. Clear? So, what you get? Root 2 into root 8y is 4y. Clear? So, you get minus 3y minus 4y. Don't forget to write upon root 2 because this is the LCM. Root 2 into root 8 upon root 2. Clear? Is equal to 0. Now, minus 3y minus 4y is minus 7y. Root 2 will again get multiplied with 0. You will get minus 7y is equal to 0 into root 2. 0 into anything is 0. You get minus 7y is equal to 0. Minus 7y is equal to 0. So, you get y is equal to 0 upon minus 7 and 0 upon anything, as we all know, is 0. Therefore, we get y is equal to 0. Once you get the value of y, now it's time to find the value of x. To find x, now substitute y either in equation number 1 or equation number 2 or equation number 3. But as I said, it's always better to substitute in equation number 3. So, let us substitute y is equal to 0 in equation number 3. What do we get? X is equal to minus root 3 into 0 upon root 2, which is 0 upon root 2. Again, 0 upon anything is 0. So, x is equal to 0. X is 0, y is 0. Write the final answer. Solution is x is equal to 0, comma y is equal to 0. Clear? Chalo. Let's move on to the next sum.